lesson is on the future value of an annuity, and we'll talk a little bit about what an annuity is and the different kinds of annuities we will be looking at. So to start, let's look at the warm-up. It says determine the sum of the first 12 terms for the following geometric series. Okay, so let's think back to the discrete functions unit where we look at a geometric series, and the formula for the sum of the terms in a geometric series are S of n equals a times r to the exponent n minus 1 divided by r minus 1. And so if you think about what each of these variables mean, a represents the first term, r represents the common ratio, so the value that you need to multiply the first term by to get to the second term, and then second term by to get to the third term, etc. And then n is the number of terms that we're looking at. So based on the information that we have in the problem, we know that the first term is 200. And the common ratio is something we need to determine, so we need to think about what value we need to multiply by each time to get to the next term. And I can see that the value that I need to multiply by is 2. One way to determine that value is to work backwards and do 400 divided by 200, 800 divided by 400, and you'll recognize that the difference is 2 between the two values. So we know that 400 divided by 200 will give you 2. 800 divided by 400 will give you 2 as well. So we know that the common ratio here is 2. And now we're also looking at 12 terms, since it's telling us to find the sum of the first 12 terms. So I also know that n is equal to 12. So if I plug in all the information I know, I have s of 12 equals 200 times 2 to the exponent 12 minus 1 divided by r was 2 minus 1. And I can do all of this in one step on my calculator. And so I get 200 times bracket 2 to the exponent 12 minus 1 and bracket. And then that gives me an answer of 819,000. And then I'm going to divide this by 2 minus 1, which is just 1. And so I get 819,000 as the sum of the first 12 terms. And that makes sense because the numbers are going to get quite large as you keep doubling them. Okay, let's take a look at the next one. The second one, we're looking at the sum of the first 12 terms. And you'll notice that the first term is 200 again. But now the value that I'm multiplying by each time to get to the next term has actually changed. So I'll start by writing down the formula. Over r minus 1. And I know that the first term is 200. And this time the common ratio, if I was trying to determine it, I can look at the ratio between the second term and the first term. And so if I divide those two values out, I get 1.05. So that tells me that the common ratio in this case is should be 1.005, so 1.005. Missed one of the zeros. And so what that tells me is that the common ratio in this case is 1.005. So I need to multiply by 1.005 each time to get to the next term. Okay, so if I plug in the information I know, then I get the sum of the first 12 terms equals 200 times 1.005 to the exponent 12 minus 1 all over 1.005 minus 1. And if I simplify this and evaluate it on my calculator, I get 200 times bracket 1.005 to the exponent 12 minus 1 and bracket. Now if I press equals, that'll give me the answer in the numerator. So that's the numerator part only. And then I'm going to divide that by bracket 1.005 minus 1. Don't forget to put your brackets because there's an imaginary set of brackets around any expression that's in the denominator. So that's the difference between 1.005 and 1. And if I press equals, it'll divide it out to give me an answer of 2,467.11 approximately. Okay, so there's what we get when we use our geometric series formula to find the sum of the terms in a series. Now this value here, or that equation that we have there, we're going to come back to, and you'll actually see this number in a few minutes in a different example that we look at. And so in a couple of minutes, we'll talk about what an annuity looks